NASA's plans for moon exploration and sending astronauts to Mars by the 1980s were delayed, and they have not yet achieved these goals. Despite the advancement of technology, NASA has not been able to send humans to Mars or resume missions to the moon. The obstacles include budget constraints and technical challenges, such as the damaging effects of lunar and Martian dust on spacesuits and equipment. These challenges have prevented NASA from returning humans to the moon and affect the future plans for Mars. By 1974, the goal of winning the space race against the Soviet Union had been achieved. Government funding for NASA was cut from 4% to less than 1% of the federal budget. NASA's focus shifted to low Earth exploration and the Space Shuttle program. NASA's annual budget has since increased by 3% to about $24 billion for 2022, and it's very expensive to send astronauts to the moon, and NASA will have to save money where it can. A reliable ship and a launch vehicle are top priority. So why not use the previously proven Saturn V rocket? NASA launched a total of 13 Saturn V rockets that took 24 astronauts to the moon. Even today, 60 years later, the rocket's performance is astounding. On a launch pad, it measured 111 meters, 363 feet tall. That's around 18 meters, 60 feet, taller than the Statue of Liberty. The first stage engines provide 7.6 million pounds, 34.5 million newtons of thrust. That's the power equivalent of 85 Hoover dams. The problem is that bringing Saturn V back to life is almost impossible. When the Apollo program ended, the manufacturing plants were repurposed or closed. Plus, more than half a century has passed and the spacecraft would need to be upgraded. Even the development of a new vehicle takes 3 years. To build an airplane, you would need 6 years. Just imagine how much time would have to be spent on a rocket with over 3 million parts. For the first time in a generation, NASA is developing a new launch vehicle called the Space Launch System. Together with the Orion spacecraft, it will be used to fly to the moon and possibly to Mars. Orion is an upgraded version of the Apollo spacecraft. It consists of a capsule for crew members and a service module. Orion is approximately 8 meters 26 feet long and has a diameter of about 5 meters 16.5 feet. To test the spacecraft, scientists plan to first send it to the moon with no astronauts on board. It will travel 64,300 kilometers 40,000 miles past the moon in about 3 weeks. This is farther than any manned spaceship has traveled before. The crew module of the spaceship is equipped with life support, power systems, and thermal protection, allowing astronauts to spend 21 days there during space missions. The test mission, Artemis I, is planned to begin in the early 2020s. A crewed Artemis I mission will last about 10 days and take astronauts as far as 7,400 kilometers past the far side of the moon. And if everything goes according to plan, the next Artemis I mission will land the first woman and next man on the surface of our satellite. Mike Serafin, Artemis mission manager, says the team aims to accomplish the goal by 2024. To keep astronauts safe, scientists have come up with the launch abort system, which consists of 3 propellant rocket motors. If something goes wrong during launch, LAS will immediately activate and pull astronauts away from the falling rocket with escape rockets. When Orion returns back to Earth and enters the atmosphere, it will reach a speed of 40,200 kilometers per hour and become extremely hot. To ensure safe re-entry from deep space return velocities, the spacecraft's crew module is protected with a large heat shield 5 meters in diameter and capable of withstanding roughly 50% the sun's temperature. But the construction of the rocket is extremely expensive and its development is behind schedule. Meanwhile, the Starship human landing system is being built for astronauts to safely land on the moon. Partnering with SpaceX, NASA developed the first commercial human lander. The Space Launch System rocket will launch aboard Orion and take 4 astronauts to lunar orbit. 2 of the 4 crew members will then be transferred to the HLS to complete the final stage of their journey and land on the lunar surface. A series of missions on and around the Earth's satellite will prepare us for the following huge step for humanity: a manned mission to the Red Planet. But taking the first settlers to the moon or Mars is only the beginning. After landing, astronauts will need suitable living conditions. The most important things are food, water, energy, and breathable air. Astronauts aboard the International Space Station, ISS, are already experimenting with growing vegetables using soil pads. Another technology involves hydroponics, where crops grow in water instead of soil. The plan is to use solar energy, but it's not an easy task. Experts believe a space station will have to be built on the north or south pole of the moon, and that rotating solar panels will be raised above the surface. This way, they won't be blocked by Earth, constantly collecting sunlight. To ensure protection against dust, NASA has already developed spacesuits coated with wax crystals that would have a slippery lotus leaf effect, which refers to the phenomenon of liquid droplets gliding past a surface in the presence of nanostructures. There are also spacesuits with a repelling electrostatic device and ultrasonic cleaning. All this technology is incredible, but things are much more complicated with the human body, as it cannot just be upgraded. A trip to Mars or a long stay on the Moon can do terrible things to the human body. In a weightless environment, bone and muscle mass starts to decrease, the heart becomes weakened, and blood vessels deform. Examinations of astronauts who spent more than half a year on the ISS showed that the brain also suffers. The frontal and parietal lobes will be affected the most. These parts of the brain control body movements. So without proper planning, the first people on Mars won't even be able to set foot on the planet. To keep astronauts healthy, NASA is implementing a research program to prepare people for long-term space flights. Loss of muscle mass and a weakened heart can be partially compensated by daily exercise. But astronauts on the ISS exercise intensely for 2 hours a day, and they still return to Earth extremely weakened. Strength training can help slow down the decrease in bone mass for astronauts. Creating artificial gravity on spaceships could address cardiac and vascular problems, but the small size of spaceships makes it challenging to accommodate a centrifuge. The idea of building spaceships that rotate to create artificial gravity, as seen in sci-fi movies, is currently not being pursued by any space agency due to conceptual, technical, and financial limitations. Astronauts also face the threat of cosmic radiation, which Earth's atmosphere and magnetosphere protect us from. Scientists have proposed solutions such as hiding behind specially built walls or wearing radiation-repelling vests. However, the full extent of neutralizing deadly radiation during long space flights remains unknown. Some scientists question the necessity of human missions to the Moon and Mars, suggesting that robots are more suitable for such tasks. Robots are cheaper to send into space and can be sterilized to prevent contamination of visited places in the solar system. Despite this, NASA believes that humans are more effective in space exploration and intends to continue manned missions to the Moon and Mars. The timeline for executing these plans remains uncertain.